This is our review recording for the material from instructional recordings A1A, B, and C in our series on angles in standard position, Unit 2, Chapter 2, Trigonometry for Mathematics 2200. In this recording, we'll do some examples associated with working with angles in standard position and the relationships between an angle of rotation and its reference angle. In this first example, which best represents an angle of 275 degrees in standard position? Well, standard position is important because we have to have our initial arm on the positive x-axis. That rules out A because the initial arm, the place where we start measuring the angles, on the negative x-axis. Likewise, option B is ruled out because the initial arm is on the positive y-axis. That leaves us with C or D. So putting in our benchmark angles, 0 degrees, 90, 180, 270, and then all the way back to 360, we should find that, or we should see that our terminal arm should be closer to 270 than it is to 360. Therefore, the correct answer is C. For this next example, we're given an angle of rotation of 91 degrees in standard position. We have to find an angle which has the same reference angle. So we begin by sketching the 91 degree angle. That would put us into the second quadrant. So it's rotating to here. The reference angle, don't forget, is the angle between the nearest part of the x-axis and the terminal arm. And in this case, since our angle theta, we'll call it the 91 degrees theta, in the second quadrant, theta is equal to 180 degrees minus the reference angle. So using that relationship, we know that theta, or 90 degrees rather, has to equal 180 subtract our reference angle. That means our reference angle must be 89 degrees. Now that we know that, we have to choose one of the given angles that has the same reference angle. 181, if we visualize that, that would only have a reference angle of 1 degree. And I'm even making that angle look a little bigger than it is. So here's a 181 degree angle. Its reference angle, therefore, is only 1 degree. So that's not going to fit. Option C, 269 degrees. That would be also in the third quadrant, very close to our 270 degree angle. But don't forget, the reference angle, it has to be made to the closest part of the x-axis, not to the y-axis. So theta is 269 there, and in this quadrant, our angle theta is equal to 180 plus that reference. So we have 269 equals 180 plus the reference, which means our reference angle must be 89 degrees. Therefore, 269 degrees is the correct answer for this question. On with the show. Over to example 3. An angle of rotation in standard position has measure such that 180 degrees less than theta less than 270 degrees. That means the angle measure must be between 180 and 270. And it has a reference angle of 21 degrees. What is the measure of theta? couple of ways to take a look at this example. One is to have to realize, first of all, that our angle must be in the third quadrant, and it has to have a reference of 21 degrees. Okay, we know it's in the third quadrant because we're told that theta is between 180 and 270. So that's what that notation there means. So it's 21 degrees here. We're looking for a full rotation, or I should say a rotation that takes us to that location from standard position. In this quadrant, our angle theta is equal to 180 plus the reference. So it's 180 plus 21 degrees. That gives us A as our answer. Another reminder is, in terms of another approach, we have a reference angle that's got to be 21 degrees. So we could construct a 21 degree angle in our first quadrant, but then use the reflections that we learned about in recording 1C, the instructional recording 1C, to get us to a terminal arm in the third quadrant. So the angle that we're looking for is not the first quadrant angle, it would be looking for this one. And again, we have theta equals 180 plus the reference angle. So either way to visualize that problem is fine. To quickly summarize, we can use our benchmark angles to determine the approximate position of a terminal arm. The reference angle is the angle between the terminal arm and the closest benchmark angle that lies on the x-axis, and the terminal arm can be reflected in the x or y-axis to obtain another angle having the same reference angle.